Okay, what we're going to look at now is what's called completing the square. So in the past you would have had an equation like x squared plus 10x plus 24, and you could factorize this. So you can factorize this into x. You look for two numbers that add to give 10 and multiply to give 24. So factors of 24 are, well, in this case, 6 and 4. So we would say 6 plus x plus 6, x plus 4. Okay, so we have factorized it, and then when it's equal to something, you can solve. Now, if you get an equation that instead is something like x squared plus 10x plus 12, this can't be factorized. Okay, so this is in a different situation. So we're going to use a technique called completing the square to make this easier to work with. Okay, and it has multiple purposes later on in maths, but for now it will just be so that you can solve the equations easily. Okay, now x squared plus 10x plus 12. What we're going to use is we're going to use the old identity, and I'm going to use some different letters here because it gets confusing otherwise. If I have x plus y squared, okay, that's the same as x squared plus 2xy plus y squared. Okay, that's our binomial expansion for x plus y squared. You did this last year. Now we are going to use this identity in reverse. Okay, so we are going to make this into a square. We're going to turn it into something that looks like this so that we can convert it this way into this form. Okay, so what we have first, you have x squared plus 10x plus 12. What I like to do with these is we write x squared plus 10x as normal, and then we're going to move the 12 over here a little bit. Okay, so we're moving the 12 out of the way because we're going to put something in here to turn our expression here into a square so we can make it like this. Now, the easiest way to find what we're going to add, because at the moment we have our x squared, you can see that we have an x squared here, that's the same as this. Then we have, this can be our 2xy. Okay, we have our 2xy. We need to know what y is though. Okay, so here we have 10x and 2xy. So the x is the same, 2y is equal to 10. Okay, so if you want to find what our y value is, or our second variable there, all you have to do is find out what b over 2 is. Okay, and I say b in terms of ax squared plus bx plus c. So if we do b over 2, then we can find out what that y is. So b in this case is 10, so 10 over 2, and that is 5. Okay, what we're going to do with this 5 is we're going to add 5 squared, because that's that y squared bit that we have over here. That's 5 squared now, so we're going to add 5 squared. Now in doing this, we have now changed our expression. Okay, we've added, well, in this case 25 to our expression, so we need to find a way of balancing that out. So we've added 5 squared, we're now going to subtract 5 squared. The net result of that is 0. Okay, so here, this is equal to 0. Okay, so it hasn't actually changed anything. All right, so that's what we've done here. So we haven't changed our expression, but now we've made it in a way that we can do something. So what we're going to do now is we are going to take this section of it here, and we're going to turn that into what we have up here with this x plus y squared. Okay, so we know that our x was just x in this case. Our y was this third number at the end here. Okay, it was this number here. And that in this case is 5. So x plus 5 squared minus 5 squared, which is 25, plus 12. All right, now we can just go further and factorize. We have x plus 5 squared minus 13. And now what we have done is we have completed the square. Okay, so this is called completing the square. This will be very useful further on. Okay, We'll do another example just to, show you in a shorter way how to do it, or a little bit clearer. So we have x squared plus 2x minus 7. All right, so the first step I always do is firstly b over 2, and in this case b is 2, so 2 divided by 2 is equal to 1. Okay, so we now have x squared plus 2x, move the minus 7 over, then we're going to add 1 squared and minus 1 squared. And if you leave it written as 1 squared, you'll remember that here 1 is your second term. Okay, so this turns into x plus 1 all squared minus 1 squared, which is 1, minus 7. Okay, and we should have equals on all of these. Whoops. Okay, which is equal to x plus 1 squared minus 8. And that is completing the square for this one. Okay, so this is now in a form that's much easier to work with, which we'll talk about in the next video. Okay, the only differences you might see is we might also have a number with a negative, and this is where you also need to be careful. So if we have x squared minus 6x minus, I don't know, let's make it 10. Okay, in this case, when we do b over 2, we have a negative b, so it's negative 6 over 2, which is negative 3. Now, a lot of people make mistakes here with this, because we have x squared minus 6x, move the minus 10 out of the way. Now, we are adding minus 3 squared, and if you use the brackets, this will make things much clearer to you later. Then we're minusing minus 3 squared. Okay, so we end up here with x, and our y term here is actually minus 3. Okay, so we end up with x minus 3 squared minus, and then minus 3 squared is 9, so we're minusing 9 here and then minus 10. Okay, you really need to be careful when you're doing these ones. All right, so this doesn't become plus 9, because you always do your index before you do your multiplying. Okay, so we always do the minus 3 squared before we subtract that. Okay, so we get x minus 3 squared minus 19. Okay, and then the other different example that you may see is an example where we have an uneven number. So if we have something like x squared minus 7x minus 8, let's not make it minus 8 because that's a nice number. Oh, it doesn't really matter for this one. Let's say minus 9. Okay, now in this case b over 2 is equal to minus 7 over 2, which equals, well, we can just leave it like that actually. Minus 7 over 2 is quite fine as it is. Alright, so here we have x squared minus 7x, move the minus 9, plus minus 7 over 2 minus 7 over 2, and they should be squared. Okay, and then when we do that, we get x, these turn into x minus 7 over 2 squared, and then minus 7 squared is 49, and 2 squared is 4, minus 9. Okay, so we've got x minus, and you can change it now to 3.5 if you like it better, 3.5 squared minus 49 over 4 minus, if we change this to over 4, we get 36 over 4. Okay, so x minus 3.5 squared minus, so 49 minus 36 is 85 over 4. Okay, and you can either leave the 85 over 4 like that, or we can change it to x minus 3.5 squared minus 21 1/4. Okay, and that's that.